Right, evening all. Nice turnout, thanks very much for coming. Right, a couple of things. One, who has come to the low carb sugar talks in the past? Just so I know who's doing the Zoom. Okay, you're going to hear a little bit about it again, because it's a very important way to get into the topic tonight. So I don't apologize for repetition, I think repetition is good. Okay, you might need to see things from a slightly different angle. That's point one. Point two, at the conclusion of the presentation, our neighbourly restaurant Sorellas downstairs are going to be bringing up some low carbohydrate, high fatty snacks, consistent with things that we profess to be healthy. So they're going to be there displayed. I think if you want to eat them, you pay them a few dollars and cents and you can eat your heart's delight or something like that. Okay, so there's something there at the end if I've made you hungry. What I want to talk about this evening, and thank you the Tin Roof people for giving me an hour of your time. And it will be a Tin Roof by 7:45. Okay, promise. Is diet, weight, and disease. And really the crux of what I want to talk about is connecting the dots. This is a hell of a big topic. So I can tell you that at lunchtime when Libby came home, I was tearing my hair out saying, I think this lecture is going to finish at about 5 to midnight. I've bitten off more than I can chew. So it's a big topic, but it's something that's been running around in my head since we started talking about low carbohydrate nutrition, trying to bring it all together. And so I hope I will do it justice in the time that I have your attention. So the dots are not just like those dots there, where everything springs from a single source, which is in a way how we've talked about diseases of lifestyle in the past. I want to show you this evening that the interconnections are pretty significant and vast and intricate. And we're going to try and deal with some of those vastly connected dots. We'll get to that towards the end of the evening. Can you all hear me with this mic? Yes? Back? Okay, you've got a secret signal back this way. Okay. The late Steve Jobs was talking about connecting dots, and he said you can't connect the dots looking forwards, you can only do it looking backwards. So you have to trust that the dots will somehow connect in the future. And when we look at nutrition and lifestyle and disease, there's no doubt in my mind that they will all connect in the future for each and every one of you. So we need to be aware of those dots. So this is the outward flowing dots that we have looked at for those who come to previous talks, and that is the relationship of diet with diseases of lifestyle, and notably diabetes, obesity, heart disease, and cancer are the ones I want to focus on this evening. And more importantly, how they are all interconnected and connected beyond just a common connection to what we eat. So tonight's objectives: have a look at the role of dietary carbohydrate and fats in what we now call insulin resistance, obesity, diabetes, heart disease, and cancer. I know a lot of you have come to listen to what we have to say about cancer this evening, and we will do that towards the end. On the way, I hope to dispel some of the myths about fat and cholesterol that we tend to have pervading our beliefs. We'll connect those dots and hopefully leave you with a little bit of healthy dietary advice. We're certainly not going to labour the point about what to eat, when to eat, how to eat, and those things this evening. We just don't have the time. But certainly we're able to connect you to our program through Linda Anstey later on if you want that sort of detail. So this slide many of you have seen before, and it's a good one to start with because it wakes people up. And there's some very important facts that you need to think about. One is that the primary fuel for providing energy to the human body is fat. Secondly, that fat, protein, and cholesterol are essentially what we are made of. And that in people like Eskimos and the Maasai in Kenya, who traditionally eat a predominantly carnivorous diet, they virtually eat only meat and no veggies and fruits, they don't develop any vitamin deficiencies, which is always a little bit of a conundrum for us, because my mother told me that I had to eat my salad and fruits for the vitamins. So how come these don't have vitamin deficiencies? The other 3 points to ponder before we go forward, which are very important. If you eat a diet which has got absolutely no fat in it, you die quite quickly. If you eat a diet that has absolutely no protein in it, sorry, that's not so clear, no protein in your diet, you also die quite quickly. If you however eat a diet which has got no carbohydrates in it, you live happily ever after. Okay, so these are interesting challenges to conventional paradigms, perhaps for some of you. So, when we target weight issues and overweight and obesity, and ask the question, why the fat aren't I thin, which will be my book when I write it. That's the title, so watch out. Okay? Give me a heads up. We are in the middle of a modern day epidemic, certainly in the first world, but not necessarily not happening here. In South Africa it's happening dramatically. South Africa is now the third fattest nation in the world. Did you know that? Okay. So they rose to that lofty bronze medal position in 2013. So it's not that far away, and I think it's going to be affecting us soon. It already is as far as we know. So, a quick perhaps summary of why we think we're getting fatter, or why we think you're getting fatter. For about 2.5 million years in human development, we were hunters and gatherers, eating a predominantly meat-orientated diet with a little bit of veggies and maybe the odd lovely luxury party when we found a beehive and we could have some honey. So the hunter-gatherer diet of our evolutionary ancestors was probably somewhere in the region of 70 to 75% fat, about 5% carbohydrates, and maybe 20% protein. Then we discovered how to grow things about 12,000 years ago. So we started to grow things from really early forms of wheat up to the modern day. In the last 200 years, we managed to take what we grow and process it in factories into nice things like Rice Krispies and all that sort of nice food that you find on the supermarket aisles. But interestingly, the greatest change in human shape has occurred in the last 35 years. In the last 35 years. And predominantly, that has got a lot to do with the fact that we've been told to eat a high carbohydrate diet. And who told us to do that? The Americans told us to do that. They convinced the world in 1977 that we should eat according to the US food pyramid. And basically, in summary, the whole base of that pyramid is carbohydrates. 6 to 11 servings of carbs a day, 5 to 9 servings of fruit and vegetables. You add all that up, it's the whole weight of carbohydrate. The Americans say we should eat 60% of our calories in the form of carbohydrates, and then fat must be less than 30%, and the balance protein. So they convinced us, in addition, because we must run away from fats, because fats are very dangerous and they cause heart disease, which I dispute. So they told us we must cut those, and we receive lots of these carbs, which of course become extraordinarily cheap. So it's an easy way and a cheap way to eat, and it keeps farmers well, which is good if you're a farmer. So the consequence of that, if you look at world sugar consumption, well, in the last 100 years it's been an exponential increase. But interestingly, if you look at protein and fat intakes, certainly in America where these figures come from, you'll notice that fat's actually gone down by about 11%, and overall calories have actually gone down by about 4%, but obesity has risen by 31% in about 10 years. So big changes with respect to diet. This is what you all believe, or most of you believe, or those of you who've never come to my talk before. The traditional model of why we get fat is based on the paradigm that we eat too many calories, we don't exercise enough, so we have a surplus, so we get fat. Yeah? General belief. Okay, even Einstein figured out that wasn't correct. It's just not that simple in human biology. Calories in, calories out can never be that simple. We are complex organisms. So basically I'm going to tell you that that's biologically unsound, that the traditional model is not correct, and obesity is definitely not a calorie disorder, not a disorder of calories. Getting fatter is actually a metabolic disorder, and that metabolic disorder hinges on how much sugar we eat, its effect on this hormone called insulin in the human body, and the net effect of sugar and insulin has the biological effect of allowing us to gain weight, which I will show you. So, I'm going to say at this point that gaining weight significantly has got very little to do with how much you eat, and it's got everything to do with what you eat. So that's key. So a quick review of carbohydrates. We're all happy with what foods constitute the group of carbohydrates? Anyone want to dispute carbohydrates? No? What's on the slide looks like carbohydrates, or was it just making you hungry? Okay. So carbohydrates in all their forms: breads, Rice Krispies, vegetables, fruits, and table sugar, all carbohydrates. So the quick fact guide to carbohydrates: all sugars are carbs, all carbs are made of sugars, all carbs end up as sugars in the human body. Some carbs digest very slowly, some very rapidly, and therefore affect blood sugar either rapidly or slowly. Carbohydrates as a fuel are a fairly poor quality fuel because they only give you 4 calories of energy per gram, which I would tell you is quite low. So they're not a particularly great super fuel. What happens to carbs when you digest them? Well, they become from more congregated sugar groupings, they simply break down into simple sugars, since all carbohydrates are made of sugars. And the commonest sugars that we find entering the human body from our food are glucose and fructose. Fructose you've all heard of, you probably associate that with fruit sugar. And actually most of the fructose in the human body comes from our ingestion of table sugar and high fructose corn syrup, both of which are the predominant sweeteners in our diet. Okay, so most of the sugar in our diet and in our food comes in the form of sucrose or table sugar and high fructose corn syrup. And when that's digested, either of those, they break down into almost equal quantities of glucose and fructose. So most of the fructose in the human diet, there is a guy called Robert Lustig, who's an endocrinologist in the US, and his hypothesis is that fructose is probably the most toxic sugar that we can take into the human body because of its effects, but that's too much detail for tonight. But I want you to understand that we don't get fructose from the fruit that we eat, we get all the fructose from the sugar that we eat. Okay, because all sugar is pretty much half glucose and half fructose. So what happens when we digest these carbohydrates into the basic sugars? Glucose will make our blood sugar go up. Everyone following me? I'm just taking you by the hand and just sort of going through the biology lesson. So glucose will go into our bloodstream and raise our blood sugar. So the donut will raise our blood sugar. And that might happen very rapidly if it happens to be the type of food that is made from refined flour, like white bread, or it is table sugar, or your refined cereals, or white pasta, white rice, potatoes, and fruits like pineapples and bananas. These foods will make the blood sugar go up very quickly, and they are called highly glycemic foods or high GI foods. If you've got a more whole grain type of carbohydrate, a more complex carbohydrate like brown rice or wild rice, most of your vegetables, your berries, apples, pears, and your fruits, most of your nuts, dairy, meats, fish, and eggs, they don't really have a very rapid impact on blood sugar, so they are called low glycemic and low GI foods. Everyone happy with that? Just illustrate the point, some foods affect your blood sugar very rapidly and some slow, and some virtually not at all. So when blood sugar rises, as it does after your breakfast and your lunch and your supper, assuming that you've had carbohydrates in those meals, there will be a corresponding increase in your blood level of insulin at breakfast, at lunch, and at supper. And that happens in every single one of us so that we can handle the incoming sugar. So here's a little biology lesson. Our blood sugar goes up. The control of what happens to that sugar is pretty much vested in this hormone called insulin. That's very important, produced by the human pancreas. And insulin then decides where that sugar is going to go. It will try and put as much as it can into your livers and into your muscles and store it there as something called glycogen. And if you are exercising, it will try and pump it in there so that you burn it. So insulin's first role is to push sugar into the areas where we can store it as sugar. But that's a fairly finite cupboard. It's not an infinite cupboard. So anything that's left over, insulin is determined to get it out of the blood. There are some people who believe that high blood sugar is particularly toxic to the human body. I'm one of them. So what does insulin do? It takes any extra blood sugar that's in your blood, pumps it into your liver. The liver is a very clever organ because your liver can take sugar and go chip, 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 chip and convert it into fat. Very clever. Sugar in one end, fat out the other. So what you see is an increase in the circulating blood fat, or triglycerides, and they'll head off to your fat stores and be stored as fat. So the lesson from the slide is that insulin is the major role player in determining fat. It converts carbohydrates to fat in circumstances where blood sugar is elevated. So you can consider insulin, as we do, the primary storage hormone in the human body. Its major role, store sugar somewhere. So, I said to you, getting fatter is a metabolic disorder going around the cycle, sugar, insulin, and fat gain. I've kind of shown you the basic biology, but I'm going to show you how this ramps up. And this amplifies in certain individuals. Because there are two types of metabolic people. Two types of people, if we look at them metabolically. There are people who tolerate carbohydrates very well. They can eat lots of bread, lots of donuts, and they look like this lovely lady here. Okay, nice and skinny, eating lots of carbs. Lucky people. But there are a large number of people who are intolerant to carbohydrates. We call that carbohydrate resistance, who will develop over time a progressive resistance to the effects of insulin, and for them, carbohydrate can be considered a dangerous or toxic foodstuff. Whereas for the carb-tolerant individual, happy days for now. People can start like that and become that too, as we shall see. So, carbohydrate resistance has got three areas I'd like to discuss. It has a strong genetic profile. It has certain things that trigger it off in different human beings. And it has significant effects on our health. So, from a genetic point of view, studies suggest that between 40 and 65% of any population carry the genes for carb resistance. Now, you know what they say about genes? You know the genes we're talking about, not so. There's another expression. Genes load the gun, lifestyle pulls the trigger. And that is absolutely true in this carbohydrate resistant metabolic profile of people. Genetics load the gun, lifestyle pulls the trigger. Okay, so you're not doomed or condemned to the outcomes of carb resistant unless you live the lifestyle that fulfills it. So the triggers we know that trigger it off: age. So as people get older, the likelihood of carb resistance developing is higher. A diet that's very high in refined carbohydrates is a known trigger, as is physical inactivity and unfitness, as is stress, especially in men, and pregnancy and menopause, especially in women. I haven't seen a lot of it in men. So these are known triggers, and I'm sure there are many more. So these are things that have been known to trigger off carb resistance in individuals, who thereby will see the effects of carb resistance kicking in over time, which is getting fat, especially in belly, developing pre-diabetes, progressing to diabetes, developing heart disease, hypertension, cancer, Alzheimer's. These are all manifestations associated with carb resistance. So how do you know if you're carb resistant? Well, you look like that, and you eat lots of carbs, you're doing okay for now. You are tolerant of them. Struggling to get the trousers buttoned up, you are showing distinct signs of carb resistance because that fatness is central. Fat in the belly. That's the key point. Belly fat is the cardinal fattening sign of carb resistance. And that fat is predominantly visceral fat, and most of it's around your organs bulging out, as opposed to only your skin thickening out. Okay, so that individual, their liver's encased in fat, their intestines are encased in fat, even their heart's encased in fat. Okay, that's just fat bulging out. Nice thought. The road of carb resistance progresses, and once you go further down this road, you are very likely to develop metabolic syndrome, which is a pre-diabetic state, which says that you are fat, you have high blood pressure, high sugar, and lastly cholesterol profiles, which we're going to look at later on. And if you carry on down the road, then the end of the road virtually is type 2 diabetes. So you can look at carb resistance as a pathway. Once you're on it, you stay on it, and the lifestyle that you're continuing to live is pulling the trigger, you just keep going. Get fat, get metabolic syndrome, might have heart disease somewhere on the way, get diabetes, in which case you're definitely going to get heart disease and then you die. Prematurely. Unfortunately. And those of you who know anything about type 2 diabetes will know that there's a strong family history in type 2 diabetes. So strong genetic drivers, but does it guarantee that every person whose dad was diabetic is going to become diabetic? No, it doesn't. The family members who become diabetic fulfill the lifestyle. Then they become diabetic. So, what happens in these carbohydrate resistant people if we have a quick look at the biology? When you're carb resistant as opposed to carb tolerant, and you develop a progressive resistance to the effects of insulin, then what happens is that every time you have breakfast, lunch and supper, and your blood sugar is going up a bit, the insulin levels go up higher and higher and higher. As your tissues become more resistant to insulin, your pancreas has to pump out more and more and more insulin to try and do what insulin does. Does everyone understand? So, the cardinal feature of carbohydrate resistance is high levels of insulin. Until such time as your pancreas becomes exhausted, at which point you develop diabetes. Okay, it's just a progression. And whilst we're getting there, the pancreas is working harder and harder and harder, producing more and more insulin to have the same effects that it did with half the insulin 5 years before that. That makes sense to you? So we go back to our biology diagram. Here's the carb-resistant person having a high carbohydrate diet. Blood glucose is pretty high. Insulin, therefore, is proportionally elevated. Unfortunately, with the increasing insulin resistance, you are able to store or unable to store the same amount of sugar in your muscles and your liver. So if you can't put it in those cupboards, where's it going to go? Well, first of all, your blood sugar is going to stay high, isn't it? So what is insulin's recourse to elevated blood sugar? Store. So the fat stores get bigger. Okay. So the carbohydrate resistant person is typified by an inability to store sugar other than in fat stores. It goes beyond that, the story. Once your levels of insulin are elevated above normal in the human body, beyond what we've just talked about, which is sugar being increasingly turned to fat and filling up that wonderful cupboard that we carry on the front of our torso, there is a second effect of insulin which is just as bad, if not worse, and that is that your fat stores become increasingly padlocked from a physiological point of view. That means you can't get the fat out. So when you're looking for energy to exercise, to think, to breathe, you can't get it from those stores. Right? You can't get it from those stores. Where are you going to get it from? Can you get it from? From what you eat. So if you cannot get it out of the cupboard at any point, what are you going to keep doing? So you can see the progressive vicious cycle that's going to develop. Okay. So once we eat more and more of these nice yummy carbohydrates which are generating this whole vicious cycle of insulin and fat storage and inability to get fat out, basically carbs are making us feel full only when we've eaten lots of them. You know, it's quite easy to eat a lot of carbohydrates, isn't it? You can eat the whole bag of them crisps if you're having a bad day or a good day. I told you that carbohydrates have got fairly low energy density. They only give you 4 calories per gram, so they don't last very long in the system. I liken the analogy to having a nice fire in the winter and feeding pine logs into it. If you feed your fire with pine logs, it doesn't last very long. Okay. As opposed to feeding it with fat, as we'll look at later, which is close to feeding your fire with hard. Okay. Lots of fuel if you want to come. So the carbs get evaporated very quickly, so basically you're going to look for more. In addition to that, carbohydrates have a fairly direct and profound effect on your brain. They actually stimulate the brain directly. Sugar does that directly, and so does wheat. Wheat, interestingly, through some of the other chemicals that are digested out of wheat into your bloodstream directly stimulate your brain. And they tell your brain, want more. Okay, be hungry. To the point that in certain individuals, carbohydrates become highly addictive. Okay, so we talk about Coca-Cola addicts, and you maybe say that flippantly. I know genuine Coca-Cola addicts. But when we have tried to remove that beverage from them, they've shown all the classic signs of withdrawal as if we had taken them or smoking or opiate drugs. Okay. Same withdrawal symptoms. So, addiction is a very real feature of carbohydrate resistant people who eat a lot of refined carbohydrate. They make it very little. So, in general terms, our world is full of sugar. All the central aisles of the supermarket are filled with foodstuffs that are carbohydrate and sugar added. So it's quite a hard life. If you like the soft drinks, which are heavily loaded with sugar, for every soft drink that you drink, it's not coming up on that one, for every soft drink that you drink per day, your diabetes risk increases by 25%. It's quite profound. For every one soft drink you drink per day, your diabetic risk goes up by 25%. How many teaspoons of sugar in a can of Coke? Not new oats that come before. New oats. How many? 13. Any other ones from 13 or 14, 12, 10.5. 10.5. Yeah. 10.5 is the answer. 10.5 teaspoons of sugar in a can of Coke. That's a lot. If you drink 2 Cokes a day, that means that you have 22 teaspoons of sugar a day, and it means that you consume 70 kilograms of sugar a year, which is approximately what the average American consumes. And if you've been to America recently, you'll see what they look like. Okay, on 70 kilograms of sugar a year. So, here's the first little bit of useful advice. The number one health intervention from a weight point of view is to cut carbohydrate by cutting down the total amount of carbs that one eats, and very importantly, cutting out the sugar and refined carbohydrates. So we talk about eating low carbohydrate nutrition programs. It's not that difficult unless you're a Coke addict like that guy. Reducing carbs just means cutting sugar out of your diet, using artificial sweeteners if you need to, and avoiding all the white starches. Sticking to healthier carbs, veggies, fruits, nuts, small amounts of complex carbohydrates. So, I'm not going to go into detail on this, but it's really an overview of how you reduce your carbohydrate. So, let's talk about the next very important nutrient in the human diet, that is fat. I use the word fat because for girls, fat is a four-letter word. It shouldn't be. It should be your friend. So, all sorts of nice, yummy fats. Very quick lesson on fats. I talk about the good. There's not many that are bad anymore. We really talk about good and ugly. It's good fats and ugly fats. Good fats are all the natural fats, all the naturally occurring fats, all the ones that you in the past have been told are bad, like saturated fats that come from animal fats, from dairy, and from coconut. You were told they were bad. They're very good. There are unsaturated fats which can be mono or polyunsaturated. These are all good, as long as the polyunsaturated fats are fish oil and flaxseed type things, which give you lots of omega-3s, and they are not polyunsaturated vegetable oils, which give you lots of omega-6s, which have got a skull and crossbones on top of them for a reason. And then there are what luckily are coming out of our diets now due to legislation. They're still there. What industry has been doing for the last 40 years, when we were told to stop eating saturated fats, they had to make something called hydrogenated fats, trans fats, to keep your food from going off all your cookies and crackers that stay on the shelf. They had to put these hydrogenated, artificially manufactured fats into them, and these are disastrous for health. Absolutely disastrous. In the States now, they're legislating to have them taken out. I think most foods in America now, you're not allowed to put trans fats in, you've got to show 0% label. But it's very recent. Those of us who are old enough have been eating them for 40 years, so bad luck for us, good luck for our children. Another thing about fats that you need to know, it's a super fuel. Fats are super fuel. It gives you 9 calories per gram, which is why it always got into trouble. It's got so much energy in it, it's going to make you fat. It's nonsense. It's just the most efficient fuel that the human body can use. Okay, you're going to get 9 calories out of every gram. You're not going to be particularly hungry in the short term like you are on carbohydrate. We know for sure from every big study on low-fat dieting and low-calorie dieting that they don't work. 95% of people who lose weight on a low-fat and low-calorie diet regain it within 24 months. 95%. That means the success rate of low-fat dieting is 5%. And also in those figures, 66% of people who use a low-fat diet lose weight will gain more weight at the end of it than they lost. By 24 months, they're actually heavier than they were 2 years ago, which is always very disappointing, and most girls can testify to that type of finding. We know it time and time again. And the major reason that low-fat and low-calorie dieting fails is because it makes you hungry. And hunger is a primal human instinct. You cannot resist it forever. In fact, for not for very long. So you go and eat. Okay? When you eat the wrong things, the weight comes back in the wrong places. Those of you who think that low-fat foods are very good for you, well, of course they're not good for you, because if you take the fat out of food, then the industry puts carbohydrate in to replace taste and to replace calories. So anything that's low carb is high fat, like the granola. And we've already said carbs make you hungry, carbs stimulate insulin, carbs make you fat. So if you're taking fat out and putting carbs in, you're getting fat. How Irish is that? It's true. I talked about hydrogenated vegetable oils, and just to make a quick point, we can talk about them later on with other diseases. These are disastrous for health. You should always check food labels for the contents of trans fats, hydrogenated or partially hydrogenated oils or fats. You've got that input back. So they are disastrous for health. They create high levels of inflammation in the body, which I'll show you are not good for any of us. Polyunsaturated vegetable oils, which we were told to switch to in the days when we were told that saturated fat was bad for us. These are very high in omega-6 fatty acids, which upset the ratio between our omega-6s and our omega-3s. Very complicated subject, just take it from me. In your human body, you want to have one omega-3 or one omega-6. Your current diet is giving you somewhere between 20 omega-6s to 30 to each one omega-3 that you have in your body. That's not good. Okay. Part of the reason for that is the fact that there's too many vegetable oils in our diet, and that we feed our farm animals who are raised in commercial farming lots of carbohydrates that fill them up with omega-6s. So the yummy cow you're eating is probably all omega-6. As opposed to the nice grass-fed organic cow is full of omega-3. Okay. So, bottom line is, we don't want lots of omega-6s, most of which come from vegetable oils. So the number 2 healthy intervention for weight is to eat more healthy fats. Okay. Now, I genuinely and seriously mean that you need to eat more healthy fats. It doesn't mean you should eat tons of fat. To a large extent, if you reduce the carbohydrate in your diet, you're already increasing the relative proportion of fat anyway. You should not be shy of saturated fats in your diet, or the monounsaturated fats in your diet, and healthy polyunsaturated fats from fish, fatty fish. Those are all very healthy things for you to eat, and you need the energy if you're not eating carbohydrate. Fats make you feel full. I challenge anyone to down a bottle of olive oil. I bet you if I put a can of olive oil, a can of Coca-Cola, I bet you the Coke drinker wins. Yes? You're not going to drink a can of olive oil, are you? So we know that you're not going to overeat oils. It's impossible, virtually. Very dense, so you've got lots of energy, so you don't run out of energy, you're not hungry again. And the other interesting thing about fats, they have no impact on the brain in terms of direct stimulation of appetite. They don't stimulate appetite. So you don't have appetite because you're full of energy, your brain's not stimulated, so fats fill you up, you have appetite. So they're very good for you. So, if we go back to our biology, when you have a lower carbohydrate, higher fat diet, in terms of what happens in your body is that the insulin goes down. Because remember, the insulin was going up because of more carbs. So now we're not eating the carbs, so the insulin's going to go down. And if insulin goes down, we stop filling up the chibubu, because we're not converting any carbohydrates to fat. And more importantly than that, the padlock is unlocked, so we can go and get the fuel that that super fuel out of that wonderful big store we've got, okay, which we can run around the world about 23 times on, which is good. And we've got all the energy we need for all the body's processes through exercise. And as we said, appetite on a higher fat and low carb diet is significantly suppressed. So as we've seen in our clinical program, people just eat themselves thin. That's what you do. You release Pac-Man into the system, gobble, 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 lots of fuel. And one day, somewhere between 15 and 18 months, if you're good with the low carb, high fat program, you look like that. And it's easy. It's easy. Because you're not hungry. Hunger is the killer in diets. A quick one here, when we look at low carbohydrate, high fat dieting or eating for diabetes, one of the most published guys in the world is a guy called Dr. Eric Westman. And I just want to quote from one of his publications recently. When you cut carbohydrates in a diabetic, you remove the need for the insulin, which a lot of them are using for their treatment, and both blood sugars and insulin go way down. He talks about his program, we're treating a few now. When you take a type 2 diabetic and you give him a very low carbohydrate diet, less than 25 grams a day, with sufficient amounts of healthy fat, you often have to reduce the insulin dose in half within 24 hours. Within 24 hours. Some of our patients off their medications in 3 to 6 weeks. Okay. So we're now talking about the potential to cure diabetes. Never been talked about before. By simply controlling the major macronutrient, which is the major driver of diabetes, and that is carbohydrate. In one study that Eric Westman posted, they managed to reduce or eliminate the medication that these diabetics were taking within 6 months. And for many of them, it's in a much shorter period of time. So, very effective. So, now you're all saying, okay, we eat all this fat, we reduce our carb, our diabetes is good, our weight's good, and we're just going to die of heart attack, so what's the point? Okay, because obviously, we've been taught that fats and heart attacks and cholesterol are somehow related, so I need to get that off the table as well. So, since the 1950s, there has been a scientific hypothesis connecting what we eat to cholesterol levels in the body and heart disease. But as I've said before in this presentation, to quote H.L. Mencken, this provided, as it does for every complicated problem, a solution that is simple, direct and understandable, but actually, unfortunately, is wrong. Okay, so it all seems to make sense. You eat lots of fat, cholesterol, your arteries clog up, so that gives you heart disease, you have a heart attack. Very logical. It's rubbish. It's nonsense. Heart disease is far more complicated than that. When we talk about cholesterol, well, quite simply, it's the most essential substance in your body. It makes up every single cell membrane in your body. It constitutes 25% of the cholesterol in the body is found in the brain. Your brain is simply fat and cholesterol, that's all it is. There's no marshmallows in your brain, although some of you might doubt that there isn't. Okay? Your brain is simply fat and cholesterol, so are all your nerves. You make bile out of it so that you can absorb fat in your intestine. All of your steroid sex hormones are made from cholesterol, testosterone, progesterone, estrogen, vitamin D, all made from cholesterol. And every one of your cells is made of cholesterol, and you repair every one of your damaged cells with cholesterol. So this terribly toxic substance seems to be fairly ubiquitous in the body and fairly useful. So we've been told that when you eat cholesterol in your diet, that's going to affect your cholesterol and your heart disease. Well, is that really true? The reality is, whatever we eat in our diet, we only absorb about half, and the contribution to blood cholesterol at any one point in time from what you eat is less than 20%. And the 20% factor with blood cholesterol is meaningless. So dietary cholesterol and saturated fat will not change your cholesterol by more than about 20%. So where does most of the cholesterol come from in your blood? And if your cholesterol happens to be high, where does it come from? Well, you actually make it. You make it in your liver and then all your cells. So 80% of the cholesterol in your blood. If I measure your cholesterol today, and it's a figure of 4, 80% of that 4 you make. Less than 20% you ate. Is there a relationship between cholesterol and saturated fat? Well, there is, but they're not the same thing. So chemically, they're not the same. Cholesterol is a sterol. which is different to a fat. They are both lipids, that means they don't dissolve in water or blood. They share common dietary sources. We know that. We get them from meat and dairy. You need to make cholesterol into bile so you can absorb fat. They share, because they don't dissolve in blood, I said they're both lipids, they share a protein system called lipoproteins to get into the blood to go to all the places they need to go. If you don't understand lipoproteins, but you know what a taxi is. You know what a taxi is. Okay, so what I'm telling you is that cholesterol and fats, they get on the same taxi. See, get into taxis and off they go. So you'll find in any of these lipoprotein taxis, cholesterol and fat. That's how they get around the body. So when you go see your doctor and he does your lipid or your cholesterol test, generally the traditional model says we worry about your total cholesterol and we worry about your bad cholesterol. Does that make sense to you? You've heard those terms? And the reason we worry about bad cholesterol, LDL, is that LDL makes up 70% of your total. So that's pretty much what we worry about. Okay? The bad cholesterol is about 70% of your total. So traditionally, if your total cholesterol or your LDL is up, then you've been taught that your heart disease risk is elevated. Everyone has heard that. Okay. It's a gross oversimplification. It is not entirely true. This is the new model. If you are a man under 50 years of age and your cholesterol is extremely high, which means you've got a major genetic defect, you have an elevated risk of having a heart attack. If your bad cholesterol is very small and very dense, which I'll talk about just now, then your risk is up. If your good cholesterol, called HDL, is low, your heart disease risk is up. And if the fats in your blood, these things called triglycerides, we talked about fats in the blood a while back, if they're up, your heart disease risk goes up. So if your heart disease risk is elevating, it's because your total's up because you're a man under 50 with a very high cholesterol, and your cholesterol's got lots of small, dense small LDLs, or your good cholesterol's low and your triglycerides up. Right, let's explain taxis. Taxis? Okay. LDL is a taxi. It's low density lipoprotein. It's a taxi that carries cholesterol around the body. And it comes in two types of taxis. And you'll understand this, because these are small, dense taxis, and they're bloody dangerous. Would you agree with that? Yeah? Anyone who lives here knows they're dangerous. So, I want you, that's dangerous. However, you can also get lipoprotein taxis that are nice and big and luxurious and safe. So the point is this. It's not just about total cholesterol levels. It's about where are they being carried. Are they being carried safely in nice, big, fluffy, safe taxis, which means your heart actually is not at risk? Or are they being carried in these tiny little bullet-like, dangerous little taxis that are going to cause damage? So it's very important. So levels of cholesterol are not the issue. How many taxis you got? Okay. Big buses, small number, can contain a lot of cholesterol. How many passengers you can get in there? Maybe about 60. How many passengers? Well, in Africa you get 60 in there as well. But really there's only like 8 seats. Okay. So the point is, if you've got all your cholesterol in a nice big container, it's actually quite safe. If you've got cholesterol in multiple small containers, it has the potential to be unsafe. Does everyone kind of get it? It's very important. So, the new model is really important because it distinguishes the size of the taxi that's taking your cholesterol. That's really probably the most important one. As for your good cholesterol and triglycerides, all of them must be taken into account. Total cholesterol cannot be considered on its own. It doesn't give you enough information. So let's look at the effects of diet on this. What is a high carb diet do to cholesterol? Well, it reduces your total a little bit, so you might consider that as a good thing. Unfortunately, it reduces lots of small dangerous taxis. It also reduces your good cholesterol, and you already know that when there's lots of carbohydrate coming in, blood sugar's high and insulin's high, what's it converting the sugar to? Fat. So those fats that are measured in the blood are coming from the conversion of sugar to fat. Okay, so when your triglycerides are high, it's because you're eating a lot of carbohydrate. And I've just shown you that these are the things that produce increased cardiac risk. So where you see all the arrows going up on cardiac risk, what kind of diet's that? I can't. In contrast, when you eat a higher fat diet and a low carbohydrate diet, things go the other way. Cholesterol might go up, might go down. We're not too fussed about total because it's about size of taxis. Okay? So now you have far less dangerous taxis and far more big buses. That's safer. You have a much higher level of good cholesterol, and because you haven't got lots of carbohydrate to convert to fat, your blood fat's going down. Important point, look at the heart disease risk. Which way are the arrows going? Down. So these are low carb, high fat diet, your cardiac risk factors go down. And that's really making people have apoplectic fits in my world. In my world of medicine and cardiology. Because that just goes against everything we have been taught. There are 25 random controlled studies in the literature that confirm this. Huge, massive, big studies, including one that was just done at Harvard, published in the Annals of Maternal Medicine, which is really set the cat amongst the pigeons, because you can't argue with those guys. They're much clearer than most of us. So, it's interesting. So, big buses are the feature of the low-carb, high-fat diet, which makes it much safer to carry cholesterol around the body. It doesn't matter what the level is. So, here are what we conclude about cholesterol. It's essential. It doesn't really make much difference to our total cholesterol levels. Yes, it's associated with heart disease, but it's most likely not the cause. It's a very weak predictor of future heart disease. It's certainly not a heart disease risk factor in women at all. And it's certainly not a significant risk factor in men over the age of 50. Arterial inflammation is, by contrast, a major factor in coronary artery disease, and increasingly we recognize that the markers of a high carbohydrate intake increase your risk dramatically. So carbohydrates and insulin and sugar are a far more significant role in heart disease. And those nasty vegetable oils and trans fats have also been shown to increase the risk of heart disease. Look at that omega-6 story and inflammation. So they're not good. Right. Diet and cancer. See, I told you we'd get there. There's a lovely hypothesis that was written way back in 1889, and it explains cancer, our ability to understand the context of nutrition very well. It's called the seed in the soil hypothesis. Have you heard of this one? The seed in the soil. It's a lovely way to look at this nasty disease. If there is a lovely way to look at a nasty disease. It talks about three processes. Process one, initiation, is the seeding of cancer in the human body. The production of little seeds, little micro-tumors. And every one of you today has got a micro-tumor. Every one of you. Every one of you has got a little abnormal micro-tumor somewhere in your body. Does that mean you're going to get cancer? No, it does not. It says you've got some abnormal cells floating around. That's initiation. And those cells become abnormal because the genetics inside the cell become damaged and mutated, and that might have a lot to do with environmental toxins, and I'm not talking about those tonight, that's a whole lecture on its own. Environmental toxins, cell phones, things that damage cells. Okay. Then there's the promotion of cancer. So the seed in the soil. The seed goes into a plant. A microtumor goes into a tumor. And this is where diet plays a major role in promoting the growth of cancer, by feeding and fertilizing cancer growth. And there are certain things in our diet that are anti-cancer promoters that can slow the rate of cancer. Everyone happy with that? And then there's the third phase of cancer, which is progression, when a plant becomes a weed and takes over the garden. Spreads. And here, diet again can promote by feeding and fertilizing not only the growth of cancer, but the spread of it. Okay, so the seed in the soil, and it makes it nice to discuss it. So, what you eat definitely has a role to play in cancer. 95% of all cancer cells cannot use fat, protein, or ketone bodies, which come from fat, for energy. They only use sugar. 95% of cancer cells can only use blood sugar for their energy processes. High blood sugar levels, therefore, feed cancer cells, worsening prognosis and increasing the chance of recurrence. I'll come back to that. Those of you who know a lot about cancer, been reading a lot about cancer, will know that traditionally the dietary associations with cancer, cancer risk, cancer growth are saturated fat, red meat intake, processed and cured meats, and there's been a lot of work on fibre, no fibre, and colon cancer. These are the traditional things. Alright? And what I'm going to tell you, and I don't have time to go through it with you tonight, is that the evidence that associates or implicates saturated fat with cancer is very poor. It has virtually been discredited. But because the old model of getting fat, the old model of eating too much fat, too many calories making us fat, still pervades. We still see stories about saturated fat and cancer in literature. But if you look at the studies that have been done to associate directly saturated fat with cancer, they failed to associate saturated fat with cancer. And that is also true for unprocessed, organic, red meat. There are no studies that show, beyond any reasonable doubt, that red meat in its unprocessed organic form increases your risk of cancer. However, how you cook it might, if you burn it, that makes a difference. And if you process meat, definitely increases cancer risk. And fibre and colon cancer is also very controversial. However, the more important evolving links for tonight are the roles of sugar, insulin, something called insulin-like growth factor, and omega-6 fatty acids. You've heard of those, eh? Yeah. In cancer growth and spread. I didn't say cause. In cancer growth and spread. So, we know that there are distinct links to lifestyle. We'll look at that again later. That heart disease, diabetes, and obesity are associated with the increased risk of what we call the endocrine cancer, breast, colon, ovary, uterus, and prostate. These are very endocrine or hormone-sensitive cancers. We know that there is a strong association with excessive intake of sugar and refined carbohydrates with cancer in carbohydrate-resistant people. We are currently, in cancer research, going through a major shift in understanding. For the last 15, 20 years, all the research, all the trials of treatment have been directed at the genetic mutations that make cancer cells abnormal. And why? Environmental toxins and all these things. But we've now understood that that's the wrong area. And you'll see that cancer research and cancer therapy is moving towards those mechanisms that continue the survival of cancer cells and their growth. We're moving away why they're cancerous, and we're moving towards why cancer cells are growing. Okay, that's important, because every one of us have got genetically abnormal mutated cancer cells. Every day we produce a few. We don't all get cancer every day. Cancer cells have the ability to avoid what all abnormal cells are supposed to do. If you have an abnormal cell in your body, it is programmed to self-destruct. It's called programmed cell death or apoptosis. That's a natural mechanism. That's why we don't get cancer, all of us, every day. Because when we have these abnormal cells, someone pushes a button and they'll see it. Okay? But some don't. So they avoid that cell death and they capture, harness, and maximize the cell metabolism to grow and to spread. And so our shift in understanding is understanding what mechanisms make this happen. What makes cancer cells immune, what they should do. And what makes them grow faster than everything else. And there's a lovely book, written by Robert Maguli, what's it called? Outliving Cancer. He's a very high-powered research oncologist in the US, and he has this lovely statement in his book, and it says, cancer cells don't grow too much, they die too little. It's a very interesting shift in understanding. This use of sugar for cancer growth was known way back. In 1931, the German scientist Otto Warburg got the Nobel Prize for discovering that cancer cells use only fermentation, which we call glycolysis in the cell water, to produce their energy. They use sugar in the fermentation process, which is a very inefficient process. We all have the ability to do that in ourselves, but we have much more efficient ways to produce energy. But they just use this cellular fermentation to produce energy using sugar. That will burn up to 30 times more sugar than adjacent normal cells. That's their fuel. They need it, and they need more for it. So cancer, in its whole mechanism, corrupts the normal cellular metabolism. The way that it does that, you've heard of this little compound, hormone called insulin. Insulin is a major role player in cancer. It uses insulin, and a very similar compound to insulin associated with insulin called IGF, or insulin-like growth factor number 1. And what these two substances do is they control the padlocks on the cell membrane to allow sugar to go in. Okay, so more insulin, more IGF, more sugar the cell can take from everyone else. And if you look at cancer cells, they've got many more receptors for these hormones on their membranes. They are therefore able to command the sugar supply in the human body. They can take much more in, so they can take it all. Okay. They use the sugar in that process to produce energy for growth, to proliferate. They use to produce it, they use it to grow. And they use this mechanism, which is very complicated, in that fermentation process. They use biochemicals produced in that process to stop that self-destruct button from being pushed. They have the ability, using that fermentation, to stop self-destruction. Once they've stopped that, happy days. Lots of sugar can grow. Okay, that's what they do. And sugar feeds cancer. Take home message. Sugar is depressed, and the other endocrine cancers that I mentioned, as cigarettes, are to lung cancer. This is what we call a PET scan, PET scan, which lights up and shows us cancer tumors and their metastatic spread. So can you see the tumor lighting up there? And this is a pelvis, and you can see this is a human thigh. Can you see that? The reason that it's lighting up is that a PET scan detects the amount of glucose being taken up into a tumor. Do you see any other part of the body lighting up? That is how much of the sugar the tumor is using. It is corralling all the sugar into its locality for use. This is actually someone who was treated, and we use a PET scan to see the effect of treatment. See? No light up. Tumor there. This person was treated, no difference. Treatment failed. Still lighting up. The reason I'm showing you that is all you're seeing in that bright light bulb is sugar. It's sugar burning in the tumor. Okay. So am I saying, and do we have the evidence to say that sugar causes cancer? No, we don't. Nobody can say that, but evidence doesn't exist. We know that it feeds it, and it definitely contributes to the splitting, multiplication, growth, and spread of cancer. That's taken as a given. So, to quote on low carbing, from this book, Starving Cancer to Death, Removing One Food, Refined Sugar, I'm going to read this to you. By reducing the amount of sugar and refined carbohydrates in the diet, the emergence of cancer can be suppressed or delayed, or the proliferation of already existing tumor cells can be slowed down, stopped, even reversed by depriving cancer cells of the food they need for survival. This is another study which I thought was well worth quoting. This was a study assessing the effect of decreasing the amount of sugar available to cancer cells in a preclinical study, and I quote from them: glucose and glutamine deprivation to typically physiological concentrations, that means there was enough sugar to be normal blood sugar, result in significant cancer cell killing after as little as 2 hours. This supports the possibility of combining anti-glycolytic treatment, anti-sugar treatment, such as carb restriction, with chemotherapy for enhancing cancer killing. So, before I connect the dots to finish off tonight, what I will tell you is there's a whole area which I haven't got time to talk about tonight. And that is, I talked about sugar being a promoter of cancer growth. But there are also a lot of foodstuffs, nutrients, herbs and spices that we call anti-promoters. They slow the growth of tumor cells. And therefore, those are things you're going to go read about, enjoy, and I will do a talk on these in the future. But green tea, dark chocolate, garlic, mushrooms, fresh fruit, veggies, berries, turmeric is a well-recognized anti-cancer promoter nutrient. The monounsaturated fats, all the healthy fats, in fact, and good old red wine. Okay, these are all nutrients with good evidence to show they slow the rate that cancer cells grow. Am I saying that these can cure cancer? No. In summary, what we know about diet is that it changes the nurture of cancer cells rather than the nature. They're probably there already because of the genetics mutate and some toxin damages the cell. Okay? But sugar and dietary factors that promote cancer will affect the nurturing and nurture cancer. Diet is definitely not the cure for cancer. We don't know that yet. But it is a vital part of a comprehensive strategy which is driven by medicine. And medicine more and more is targeting cancer with therapies that are going to interfere with the metabolism of cancer cells. All the new cancer research is how do we stop, how do we block insulin? How do we block IGF? How do we block sugar getting into cancer cells? And when it's in, how do we stop it from being used? That's where all the research is now. It's amazing, isn't it? And in time, we may get to some really good cures for cancer once they unlock the secrets of cancer cell metabolism that we're starting to peel away at that knowledge, which is really exciting. So, in summary, you have a little bit of time for me to connect the dots on what I've said this evening and see how interconnected all these conditions really are. Carbohydrates are the cause of insulin resistance, obesity, metabolic syndrome, diabetes. Carbohydrates elevate sugar and insulin, which creates internal inflammation in the body. We know that high carbohydrate intakes are associated with increased risk of the endocrine cancers. Celiac disease, which is an intestinal disease, a severe disease as a result of wheat intolerance, not just gluten intolerance, it's a severe disease, but it's a result of wheat, is associated with a 30 to 40 times increased rate of bowel cancers. Now I've just shown you that carbs feed cancer cells. So there's some dots there. We look at obesity. I showed you that obesity in the tummy, that's a significant issue. It is so significant that it becomes an endocrine organ. Out of abdominal fat, you secrete huge amounts of estrogen. Estrogen and breast cancer and ovarian cancer are very closely related. So it becomes an endocrine hormone secreting system. It also secretes thousands of inflammatory chemicals. So obesity creates body inflammation. 80% of type 2 diabetics are obese. Waist circumference is a powerful predictor of diabetes, heart disease, hypertension, cancer. Okay, so if you're obese, you have 2 to 4 times increased risk of breast cancer, colon cancer, and obesity is the second highest risk factor for cancer after smoking. It's also a predictor of dementia, including Alzheimer's, that is obesity, and waist circumference is a direct predictor of our mortality. The better you are, the shorter your life you live. When we look at women with breast cancer who are overweight, they have higher recurrence rates of their tumours, they have a 540% increased death rate, they respond poorly to chemotherapy, and they have far more side effects of radiotherapy, quite simply because they're bigger. So the amount of radiotherapy you've got to aim at them is going to be more and deeper, so they give more side effects. Inflammation. It's associated with belly fat. It's associated with a high intake of vegetable oils, those omega-6s and trans fats. It's associated with high blood sugar and insulin levels. It's strongly predictive of diabetes, implicated in heart disease, because inflammation is involved in atherosclerosis, and it's implicated in the growth and spread of cancers. Inflammation is fertilizer for cancer. That we know. Talk about heart disease hinges around inflammation, not about cholesterol, it's about inflammation. And caught up in that inflammation are those dangerous taxis carrying the cholesterol. So oxidation of cholesterol in an inflamed artery is a contributor to atherosclerosis, and we know that that's largely driven by high levels of sugar and insulin. Diabetics have a double risk of having a heart attack. If you're obese, you have an increased risk of having a heart attack, and we know that trans fats, vegetable oils, and higher omega-6s in the body increase your risk of heart disease. Do we see these dots? Lots of crisscrossing. Cancer. Inflammation is a fertilizer. Obesity increases cancer growth, and I showed you how it impacts on breast cancer treatment. Diabetics have higher risks of cancer, of the endocrine cancers. Cancer cells proliferate in a highly sugared bodily environment. They double the risk of breast cancer if you have a high trans fat intake from those horrible industrially manufactured hydrogenated fats. Interestingly, if you have a high cholesterol level, you have a markedly reduced risk of developing cancer. If you have a very low cholesterol level, you have a markedly raised risk of developing cancer. Who the hell wants low cholesterol? And so we know that environmental factors, especially diet, are more important than the genetic mutations that generate cancer. The environment in which that cancer cell, that precancerous cell, that microtumor is going to enter into, is more important than the fact that it exists. So in summary, is the advice for what you eat. If you want to be lean and healthy, cut the carbs, especially the refinements from your diet. Stick just with the healthy veggies, fruits. Sharpen the healthy fats and don't be afraid of them. Eat a low carbohydrate, high fat, moderate protein diet. Do a reasonable amount of exercise. I think carbohydrates should be considered a weapon of mass destruction. As John Stuart Mill said, and some of you might doubt me, going forward this will become increasingly clear. That which seems the height of absurdity in one generation often becomes the height of wisdom in another. That's where we're going. For some of us, that's where we already are. We have a very good program here at Rolf for weight management. We are looking at some diabetics as well now. So Linda and Steve, you met on the way in. We'll send this out on email to you. Left us your emails. If anyone's interested or knows anyone who might want to benefit from that program, you're most welcome to come and talk to Linda. Thank you for listening. Enjoy the snacks. I'm happy to take some questions. I hope that was worth your Friday. Thank you very much.